Hello, this is Tamisha with Educational Tutoring Centers. I have a problem for you that's asking me to solve for the variable using substitution. I chose this problem. It was interesting to me. I was working with a student today online, and I thought this problem was interesting because it's asking for us to use substitution when we have an exponent of only 2. Well, typically you use this type of substitution on these equations when you have an exponent that's higher than your square. So when I was in college, we called this type of substitution u-substitution. And so u-substitution, I'll just abbreviate that. And what we do is we take an expression that may be a little more complex to manipulate, and we simplify it and then later reapply what we substituted at the beginning of the problem. Okay, so here we have 2x minus 9 here and a 2x minus 9 here. And if you try to expand this out and go through and try to solve for this using traditional methods such as square root property, completing the square, quadratic formula, anything like that, you'll find that you're not able to solve for your x's. And so this is why we use this method to get to our value. Okay, so u-substitution. So we have two expressions that are identical, and we're going to pull that expression out and substitute it with a variable. And in this particular problem, we're using the variable u as opposed to x because we already have x there. We could use any other. We could use a p, s, t, any other variable, but typically in our college courses we use u-substitution. Okay, so here those are identical, and so we want to set this equal to u. So once we substitute that expression, we'll end up with u squared minus 6u minus 27 equals 0. So now if you look at that, you say, hey, this is not as complicated as I thought it might be from this original equation. So now this looks like your typical trinomial, and you can open your two parentheses and go ahead and do your factoring. So there's our two parentheses. We have a u squared, so we're going to apply the u here and the u there. We see here that we have a minus, and so we know that we have to put in opposite operations. And the reason why we have to put in opposite operations is because if we go through and we do the FOIL on these factors, when we do our multiplication of these terms that are here and here, they have to be opposite in order for us to get that negative there. Now the other thing that we notice here is that we have a minus sign here, and so we'll need to, once we figure out which factors to use here and here, we'll need the larger of those factors to go with the minus in order to get a negative here for our middle term. Now a lot of this is foundational, so by the time you arrive at this college course, you have already seen factoring. You may have done it any number of ways. You use whichever method works best for you. Okay, so here's our number 27, and it's a negative 27. So I'm just looking at the factors of 27, and they're 1 times 27 and 3 times 9. Those are the only factors of 27. And so we're looking for a combination of opposite signs that will give us this negative 6 in the middle. Well, we can put a negative with this 1 or the negative with the 27. Either way, when we go through and do that portion of the FOIL method, it's never going to get us to a negative 6. But here, if we look at this 3 and a 9, if we put a negative with one of these, we are more than likely going to get to this negative 6. So I know I need the larger number to be with the minus in order to get a negative. So I'm going to put this 9 here and the 3 here. Now before I go further, I'm going to test myself. And I use what I call the smile method because I multiply the 2 outer terms and the 2 inner terms. And that's how we get to this middle number here. So here, if I do a u times negative 9, I get a negative 9u. And if I multiply these 2 inner terms, I get a positive 3u. And when I combine those two, I get a negative 6u. And that's exactly what I needed right here. So I know I have found the proper combination of factors here. Okay? So then the next thing I do is I take each one of these factors because it says this factor times this factor is equal to 0. So I'm setting each one of them to 0 so I can find the zeros of my graph if I were graphing, and I'm not graphing on this particular problem. But if I needed to graph or find the places on my graph where the graph crosses the x-axis, those are called my zeros, and this is how you solve for them. Okay, so I took this expression, set it equal to 0. Now I'll take this expression and set it equal to 0. Alright, so if I subtract 3 on both sides, I will get u is equal to negative 3. And on this one, I have to do the opposite operation to solve for u. And so then u is equal to 9. Now I'm not finished because the original problem had x in it. Well, I went through and I did my substituting and I put my x expression set equal to u. So now I'm going to substitute this back into this equation. So I have 2x minus 9 is equal to negative 3. And for this one, 2x minus 9 is equal to 9. Okay. Now the reason why I have 2 portions here is because, again, this is a graph of a parabola when you have x squared. So it's going to do something like this. And it crosses your x-axis at a couple points. And remember that a parabola is symmetrical, but this one will have a little bit of shifting to it, and that's why you have this minus 9 effect here. So anyway, we're looking for 2 solutions, 2 places that it's going to cross the graph. If you had a parabola that did this, then you would not see solutions where your parabola is crossing, or you might have a graph that does something like this, where it only touches that one point, which will give you one solution. Okay, so let me do this here. Alright, so let's go back to this problem here. We're solving for x, so I'm going to add 9 on both sides. Gone. 2x is equal to 6. Dividing by 2, divide by 2, and x is equal to 3. That's one solution. On this graph, on this equation, I'm going to add 9 on both sides to solve for x. And so I have 2x is equal to 18. Divide by 2 to solve for x. And so x is equal to 9. So those are my 2 solutions. So if I were graphing, I would have a coordinate plane looks like this, my x and y axis, and my x solution would be here at 3, and I would have another one here at 9. And if I wanted to further analyze this graph, I could look to see what the bottom part of my graph is, which would be for this one a minimum because my x is positive, and so my graph would open up something like this. So once I solve for this bottom point, then I would be able to see how far I needed to draw down, and that's what my parabola will look like. So it has 2 real solutions. Okay? So that is it for this problem. You would write your solution such. Okay? Alright, let's look at this next problem. Leave that out. And here's our second problem. Now, if you notice on this one here, you have a power of 4. This is your typical type of problem that you would use u-substitution for. Because you can't really open 4 parentheses and try to factor this in any easy kind of a way. So this is a graph that I could put it in my graphing calculator and look, but it's something that's going to cross your x-axis a maximum of 4 times. So it may do something like this. Okay, so that would be 1 solution, 2 solution, 3 solution, 4 solutions. That's if the solutions come up as real numbers. But there may be a situation where you come up with some imaginary numbers, or you may end up having a couple real solutions and maybe 1 imaginary, or any number of imaginary ones. Okay, so let's go ahead and look at this problem. On the last problem, we had our x variable being identical, and we could just choose it and do our u-substitution, but these two don't look alike. So what I'm going to do is I'm going to look here at the x to the 4th and see how I might be able to make it look like an x squared, since I do have an x squared in there. Then I have 2 things that are identical that I can make an equal substitution for. So if you think back to your laws of exponents, your rules for exponents, when you raise a power to a power, you multiply those exponents, and that's how you would get that. So let's see if I can show you what I'm talking about. Here, I'm looking to get an x squared, so I want to try that. And then I would say, what do I need to raise this power to in order to get this exponent of 4? Well, I would need to raise it to a 2, because a power raised to a power, or power raised to an exponent, you multiply them, and then that's how we get this number here. So x to the 4th is equivalent to x squared raised to the 2nd power. So I'm going to first replace x squared with, x to the 4th with x squared raised to the 2nd power. And then everything else I'm just going to write exactly the same. Okay, now I can do my substitution. I have an x squared and an x squared, so I can pull those out and then get an expression or equation that's something that I'm familiar with. So we're going to say that x squared is our u. So here, when I do my u substitution, I'm going to replace my x squared terms with the letter u. So that's u squared minus 21u plus 5 equal 0. Okay, so now here we are with a trinomial that looks familiar. And so what we could do is open our sets of parentheses and go to work. So in order to figure out which factors we need in here, we have to look at the coefficients on the first term and the last term, of course. So we have a 4, and the factors of 4 are 1 times 4 and 2 times 2. And the factors for the last term is just simply 1 times 5. Now we can go through trial and error, which a lot of students are taught that. There's some other strategies that people take, such as taking this middle term, finding its factors, and splitting it up. But what I'm going to do is go ahead and just do a little trial and error, since we only have 2 pair of factors. So the first one I'm going to use is a 4, and of course this is u squared, so there's a u. And the other one is a u. And I have a plus sign here, so whenever I have a plus sign on my third term, I'm going to use this sign in both parentheses. Okay? So my factors for 5 are just 5 and 1. And it's negative. Both of my signs are negative, so it doesn't matter. yeah, it does matter where I place my 5 and my 1 because I still need to get to this number of 21. So just thinking about it, if I put a 5 here and I put a 1 here and then I do the smile method, well, a 5 here and a 1 here will only make 4 and 5, which will make 9. So I know that's not going to be what I need. So how about if I put the 5 here and the 1 here? Now I'm going to check my smile. Okay. So 4u times 5 makes a negative 20u. And here, my inner terms, a negative 1 times u is a negative u. And so when I take, if it were 20 degrees below outside and it dropped down 1 more degree, then that would be negative 21u. And that's exactly what I need here. If I had a place of 2 and a 2 here, which is this other factor, it would have been too small when I did the smile method to get this number here in the middle. So now, just like before, I take this factor, set it equal to 0, then this factor, set it equal to 0. So let's do that quickly before my video gets to be too long. Okay, I'm solving for u. So u is equal to 1/4. And then here, u is equal to 5. Okay, so those are my two u values. But remember, we were originally asked to solve for x. And those x's are zeros where they cross the x-axis. So what we need to do now is look at our u value, which is x squared, and substitute it in place of u in our solutions there. So we'll have x squared is equal to 1/4 and x squared is equal to 5. Okay, so we're solving for x, not x squared. So the way we undo this x squared is take the square root, and we do the same thing on the left and the right. So those cancel, leaving me with x is equal to the square root of 1/4, which could also be written like this. And the square root of 1 is just 1, and the square root of 4 is 2. And this is plus or minus whenever we take the square root. So that's 2 solutions of the 4 that's possible that we can have. And then we take the square root of this one. And so then x is equal to plus or minus 5. So there's 2 more possible solutions. So our solutions are -5, -1/2, 1/2, and 5. And all I did was put them in order from least to greatest. Okay, so those are the possible solutions. They're all real numbers, something you can identify on a graph. So you might have a cross the x-axis here, cross it again at -1/2, cross it again here at 1/2, and then cross it again here at 5. So it would do something like this. Okay, I think that should be it for this graph. Thank you for watching. Please be sure to like the video and to subscribe so you can see additional videos as they are updated. Have a good day.